Yeah. So we are going to discuss about the index. So what is the normal before going to the index? Let's see one thing. Basically, we will be having dictionaries, right? Dictionaries means we will have all words and the meanings and other thing, right? So how it is going to be in the dictionary? It's going to be in the alphabetical order, A to Z. The words are in the alphabetical order. Let's assume that they are not in the alphabetical order. Then if you want to find some data, how you are going to find? Then it takes lot of time for finding a particular word. If all the words are not in the alphabetical order, you may have Z, you may have D, you may have F, you may have K, you may have A, like that. It's not in alphabetical order. Then what happens? It takes much more time. So if you do in alphabetical order, then for finding any in the dictionary it is alphabetical order, right? So what happens if you want to find any word, it is easy, because if you want to find some sweet word, first what you will do, you will go to the S alphabet, S word. Next from there you will go to the next second word as W. After you will go again with the third word as E. Then it is easy for you to find the word. Like similarly in the tables also. So whatever the thing that is happening to our real life, the same thing will happen in the table also. Let's say in the table we got records. Okay, I'll just write one. Just say we got, this is a table. In the table we got records from 1 to 10. Let's say 1 to 10. Okay, we got 10, we got 8, we got 6, we got 7, we got I think 9, 1, 4, 5, like this we got. Let's say if you want to find one record, okay, let's say, yeah, we got one more call, we got 10 two times. Okay, we got 10 two times. Let's say we want to find 10, we want to find 10, or we want to find some 8. Okay, what system will do? System should go and check each and every record. After checking all the records, then it gets the matched value. Means it scans entire table. It scans entire table. If you want to find 10, it will go to each and every record, see, and after that, so it got like how many times it is going to see here, it is going to see here. Even though it found the 10th record, it will not return back. It will again check other records also. Each and every record it will check, and one more time it found here, because it is not sure whether it's only one or two times, right? So it need to check each and every record to find that matched value. Okay, to find matched 10, it will not return immediately after finding 10. It will go and check each and every record. After checking each and every record, so once it is done with entire table scan, then it will go and insert this 1, 10, 9, 4, like this. Okay, this is a thing that it does. Okay, now let's see one thing. So that is nothing but the table scan. Table scan means it will not at all it will scan entire records. I think last time we inserted one record. Okay, sorry, this is other one. Databases, test, tables. Yeah. Let's do select from 1000. Select top from 1000, something like that. Okay. So in this table, basically we can see whether the table is doing the index scan or not. How can we do is that just select this table, and there is one option called query execution, estimated execution plan. Just click on that. When you do that, it will do, see, you are getting table scan. Means suppose if I do where id equal to some 10, and if I execute this, okay, and if I just select this, and if I just select this query, or just I can do the execution plan. So what it is doing, it is taking the cost, means it is doing the table scan. See, in order to get the data, okay, so select statement is just taking only 0%, but table scan is out of 100% cost. Table scan is occupying all the 100% cost. Means in order to find the value for id equal to 10, so it needs to go and check each and every record. That is nothing but the table scan. So this execution plan is nothing but it will check which is the easiest way, which will be the fastest path to get the data. That will be the execution plan. Okay, by default system will show, nothing to worry, I'll just explain at the eye level. So it is doing a table scan, means when you click on this you can see physical operation, this all, right, estimated operation cost, number of rows record, that all it will be showing, input output cost, CPU cost. Don't worry about that, just worry about the is here the cost is 100%. Okay, see, that's it. So in the select it is not taking any cost, it is not occupying any cost with the select, but total, out of total cost it is just occupying this cost. The total cost is only on the table to scan the data. Okay, that is the thing. Now let's assume if the data is in a sorted form. Okay, if the data is in a sorted form, so if when the data will be in a sorted form, let's say, we sort the data here, this data, whatever data we got, we will sort. So what is the thing? It is 4, it is 5, it is 6, 7, 8, 9, 10. So this is the data. So what, suppose if you want to find some 10 record, okay, suppose if you want to find some 10, so what it will be, first system go and check some data. Okay, it will check 7. Okay, it is not the record, so 10 is greater than 7, right? So again it will go and check after some record, mostly within second or third search. So you will be having 2 10s, right? So mostly with second or third search you will be getting the 10 value, but here it will search 1 2 3 4 5 6 7 8 times, it will search 8 times, but here it will just, you will be getting the data in first or second or third search. Okay, how it is going to search, we are going to see. Basically it follows the binary method. We are going to see about this in detail. Okay, now see, so this is a table. Now I'll create an index on the table. How to create an index? I'll sort it, I'll sort the data. So always, what is an index means, you create a table. Normally when you sort it, basically whenever you sort, actually this is a table. Okay, so this is a table. In the table you got the data 8 9 6 5 4 3. Okay, this is the thing. Now what you are going to do, if you sort it, what happens, that the table, the data in the table will be as it is, nothing to worry, but another space is occupied by the index that will have all the sorted values 3 4 5 6 8 9, and if you want to get some value, first it will come and check that value 6. Okay, and next it will go and get that, it will just internally it does everything and you will get that value. So index is nothing. Whenever you create an index will occupy additional space along with the table will occupy, because the table needs some space to store the data, right? So if you create an index, automatically that index will also have some, it will also occupy some space, because index is nothing but it will sort the data and store the data in a sorted way. Okay, for in order to do that, it will also occupy some space. Now you can see on the table, I'll just right click and see the properties. When I see the properties here, you go to the storage. What is the total thing? By default you will be having the index as 0.08. Okay, by default you will have that is a 0.008. Now the total data space is 0.070, right? Now index is 0.80, total record count is 5000. Okay, now what I am going to do here is that yeah, let's be up to 5000, it's enough. Now what we are going to do is that just we are going to create an index. After creating an index, we will see the space, index space. So the property storage. Now that data space is 0.070 and index space is 0.008. By default it will be the normal minimum size. Even though if you don't create, by default it will be that size. Now let's see and go and see while creating index. So same, whenever you want to create an index is also one type of object. So for creating an object, you will always use a create command. After that, object type. So I need index. Okay, and next I need to create an index name. So basically I'll give index as idx underscore, and what name I'll be giving, since I'll also give the table name idx underscore, because you need to find that, right? You need to differentiate loop, and on which column I am giving id. That's it. After that, here you can give the index type. Okay, create cluster. I'll explain about the cluster. What is a cluster and non-cluster? We will going to see. Yeah, by default we will give that. Oh, what is, I forgot the syntax for the index. Oh, sorry. Yeah, create index on table name. The table name is WLOOP, and here after that on index, and I'll give the column names. What are the columns I need to give? Oh, it is a WLOOP, right? Table name is WLOOP. Okay. After this, I'll give the column. What is the column name? ID as ID, right? So I can give whether I want to sort it by ascending order, I want to sort it by descending order, I can give it. So I'll just sort it by ascending order. So if you don't give anything, by default it will sort it by the ascending order only. Done. Okay. I'll get an error because I'm in different database, right? I'll just go to the test and see. Now I'll just create it. Here you will be giving create. Yeah, create cluster index. Okay. Now I'll just create the index. Done. Now index has been created. So whenever I create an index, if you want to see the index, see here. When I click this, you'll get that index name. IDX WLOOP ID. This is the index that I have created. Okay. So now what I will be doing, I'll just close the query. So let's see. I'll just take say same top 1000 rows or something like this. I'll just remove the top 1000 rows. Okay. Now I do the execution. I'll give where ID equal to something. ID equal to 10. Okay. Now I'll see the execution query plan. See. Okay. Now you can see. Previously, what is there? It is there. You can see it is a table scan, right? Now you can see it is showing index seek. What is seek and scan means? Scan means it sees every one record. Let's say this table doesn't have any index, right? So we'll just go to this table and see the proper execution plan for this. Select star from, okay, table. Just I'll write the table name. I'll just do this and do the execution plan. Oh, which database it is? Test only, right? Yeah, it is a like, yeah, sorry, I need to change it to the test. Okay. Now I'll just do select star from and do this. See, it is doing index scan. Scan means it will go and check each and every record. Okay, we are going to worry about the scan and seek later on when we go to that when I explain the difference between cluster and non-index types, then we can see in depth. Just only time being I am showing what is the index. Okay, so this is a table scan, but you can see here for this, you can see here scans. Just remember the scan word. Now you can see when I do this, now you can see it is a seek, table seek. Previously for this table also it was scan only, but now after creating index, it changed it to seek. Okay, what is that? I'll be showing now. Okay, now see the table. If I go and right click and see the properties of the table, go and see the storage. See, previously the index size for the same 500 rows for the same data, it was 0.08, 0.008. That was the default size. But after creating index, what is the size for the index space now? It is 0.016. So it means that whenever you create an index, it occupies space. Means nothing but it is ordering the data and storing at some location. Okay, that's why index also occupies the space. When you have huge data and if you want to create an index, then it occupies space. So what are the points we discussed? We just, if the table doesn't have an index, okay, and see one more thing, on what column I am filtering here, okay, that column should have an index. Since I am filtering on ID, right, that column should have an index. If I don't filter on ID, if I filter on, suppose let's say the column has some name column, okay, if the name column is not having any ID, if we don't have any index on the name column, then it is waste because it is not sorted, right? So then it will just use a table scan only. Okay, we are going to learn much things about the index today. So what we have seen whenever there is no index on the table, it means that it does a table scan. If there is an index, then it is nothing but you are sorting the data, and if you want to get any data, any results from the sorting data, then it does the table seek. Okay, that is thing. After that, whenever you create an index, it occupies some space. That is the only thing you need to remember up to now. Okay, next I am going to explain in depth other things. What are the other things means? What is the index? How many types of index we have? As we seen, what we have seen up to now, we have seen index also occupies space. Okay, now there are two types of index. One is a clustered and another is a non-clustered. I'll just explain about the cluster, and just we can say about the non-cluster. Okay, so when we have the cluster index, let's say the data is this one. We have the records called 5, 2, 5, 1, 3, 4, 6, 9, 7, 8, 10. These are the records we are having up to 1 to 10. 1, 2, 3, 4, 5, 6. We are having 10 records. So when we create an index for the 10 as a cluster index, how these records are stored means internally. What is the middle record out of 10? 6 will be the first, that 6 fifth, if you sort them. So let's say the middle record is 6-1. Okay, 6th middle record will be at the top. After that, less than that record will be at left side, and greater than that 6 will be at the right side. So less than 6, what are the less than 6? 1, 2, 3, 4, 5. So out of 1, 2, 3, 4, 5, so you will have 1, 2, 3, 4, 5. Out of 1, 2, 3, 4, 5, which is a greater number? Let's take, we take like n plus 1 by 2. I think they will take that as a middle number. N plus 1 by 2 means it is like, if the count is even number, then they will do n by 2. If the count is if the count is odd number, then they will do n plus 1 by 2. So it is like 5, right? 5 plus 1 is 6. 6 by 2 is 3. So this will be our middle number. Okay, so that will be at the center. Now what will be having here? We'll just go to other one. I think here you will have 5 here. Yeah, by default we'll keep. Okay, I'll start from the beginning then. Okay, how the data is stored means 4, 5, 6, 7, 8, 9, 10, and one number will be at the center, and the smaller numbers will be stored at the left side, the greater number will be stored at the right side. Again, out of that all lesser numbers, in that numbers it will again take the smaller number. So in these 10 numbers, how to find the middle number is that basically it is the system is going to do. You are not going to do anything, but just only to understand, I am going to show how the system is going to do. If the total numbers are in the even way, then it will take n by 2. If the total numbers are odd way, then it will take n plus 1 by 2. So 1 to 10 are even, right? 10 numbers are even. So 10 means 10 by 2 is 5th. 5th number will be at the center. After that, what happens? The other numbers, like, so 1, 2, 3, 4 are less than 5. 6, 7, 8, 9, 10 are greater than 5. So less numbers will be at the left side, greater numbers will be at the right side. So here 1, 2, 3, 4 will be at left side. So in the 1, 2, 3, 4 they are even. So 4 by 2 is 2. So 2 will be at the center. And again 1 will be at the right, and again 3, 4. 3, 4 means only 2, right? So that 2 can be placed at the here. Okay, that is the thing. Or you can directly keep 4 will, so 2 by 1 is 1. So 3 will be at the center. After that, for the 3, 4 will be at the right. That's it. And after that, now 6, 7, 8, 9, 10. So here 8 will be at the center. It is out of 5 words, 5 plus 1 is 1 plus 1 is 3, right? So third letter is 8. So 8 will be at the center. After that, 6, 7 will be at the right, and 6, 7 will be at the left, 9, 10 will be at the right. And out of 6, 7, so which will be the normal thing? 6, 7 means, yeah, let's take this 1, right? So 6 will be at the thing, and to right side of the 6 will be 7. Here 9 will be at the left, 9 will be at the center, and right side of the 9 will be 10. So this is the way how the data is stored inside the index. Okay, inside the index the data is stored this way. If you create an index on these numbers, then at the back side this data is sorted in this way. This is nothing but the binary tree. Here let's say if you want to find 10 value, how easy it is. See, I'll go and check at the top. This is a root. this the edges value are the leaves. Okay, any edges value are the leaves. So now root, if I want to see 10, how many times it takes? See, now the data is not sorted. If you want to find 10, even though 10 means what I said, it will scan the entire table, so it will do 10 times. It will go and check each and every record, so it will do 10 times to find the 10 value. Even though you found here 10, but it will not wait. Again, it will go and check each and everything. Okay, now let's see here how many times does it take. So 5. 10 is greater than 5, right side. This is a one time, right side. It comes here, it will check 2 times. It will check here, 10 is greater than 8, so right side again. It comes here, so it will check here third, and 10 is greater than 9, so right hand. In the fourth step, it found the value, but whereas here it needs to do 10. That is only for the records, less records. If you have some millions of records, then it is again a separate issue, right? So that's why, like, then the difference will be more. If you have millions of records, you may find only in the 10th step, but here you may find in million step. Okay, that's it. That is the difference between the when you have the index, how the data is stored in the binary tree format. The middle value will be at the root, and the less than that root value will be at the left side, greater than that root value at the right side. Nothing to worry about this, but only you need to understand what is meant by this. That's it. Okay, how the index are stored at the back end. Now, yeah, I think my video is done. I'll just stop the video and again re-record it again.